Arthur C. Clarke had a sequel to 2001 A Space Odyssey. It's called 2010 Odyssey 2, and at the end of it, an alien intelligence converts Jupiter into a star. As a group of astronauts narrowly escape the implosion, they receive the following message from the aliens: all these worlds are yours, except Europa. Attempt no landing there.
Now, that was just a novel, but it suggests that already in 1982, we suspected that Europa might offer our best chance of finding alien life in our solar system.
42 years later, in October 2024, NASA is actually launching the most advanced mission to hunt for signs of alien life. And it's going to Jupiter's moon, Europa. There's just one problem. Jupiter kills everything around it. So how could life even exist there? And how do you make a probe that can withstand the perilous conditions? Deep inside Jupiter, there is so much pressure that hydrogen is believed to take the form of a metallic liquid. And this metallic liquid hydrogen generates an incredibly powerful magnetic field, almost 20,000 times stronger than Earth if you measure at the same distance away. So if you could see this magnetic field from Earth, it would appear twice as big as the full moon. On its own, that magnetic field is harmless, but right in the middle of it is the most volcanically active world in the solar system, Jupiter's moon, Io. The volcanoes on Io's surface shoot out tons of sulfur dioxide, and every second, 1 ton of this material gets ionized and trapped inside Jupiter's magnetic field. And the field accelerates these particles to rotate incredibly fast with Jupiter, so they whiz around at over 300 kilometers per second. Their inertia actually pulls back on the field, stretching it out. And this trapped material slams into other moons, ejecting even more particles from their surfaces. This cycle forms massive radiation belts which span past Europa and the other moons of Jupiter.
Now, for electronics, this intense radiation is kryptonite.
In the 1970s, the PioneerTen and Voyager missions only briefly passed by Jupiter, but the radiation caused glitches, gave the instruments false commands, and corrupted some of their data. Even with modern shielding, a spacecraft within the radiation belts would only survive for around 3 months. So how will NASA's new mission, the Europa Clipper, orbit Europa for over 4 years without getting fried? Well, the solution is it won't.
It'll orbit Jupiter from afar and then swoop in every few weeks to quickly fly by Europa and then leave again. And since the mission is going to collect a lot of data, it can use the downtime while it's way out here to transmit it all back to Earth before going in for another swoop. In all, it'll do 49 flybys, mapping almost the entire surface. That's actually how the Clipper got its name, after the fast and nimble 19th century clipper ships, quickly dipping in and out of ports. But of all the places in the solar system to look for life, why Europa?
If you stood on Europa's surface, you'd be hit with 5,400 millisieverts of radiation in a single day. That's 1,800 times more than the annual dose here on Earth. If you stay here for a couple hours, you would eventually die from radiation sickness. But Europa contains a secret. When Voyager 1 passed by Jupiter in 1979, it took this photo of Europa. If you compare that to most of the other moons in the solar system, you'll notice something is missing. Craters. Every planet and moon has been bombarded by asteroids over billions of years, and most planetary surfaces show it. But not Europa. So why not?